Hello student, let's start today's session. With the screen you can see SSL and TLS fundamental. In this session we are going to cover few topics which you can see in the screen. The topics you can see here is HTTP with HTTPS, TLS handshake, certificate types, root with intermediate CA, public with private certificate, and key store with trust store. So guys, this topic is very important for the senior guys along with the juniors who has a good hands on a server or application server. We will implement this concept in Apache Tomcat as a web server. So in this session you will see what will be the difference between HTTP and HTTPS. So we'll see what is a difference between HTTP and HTTPS. Here you can see points that I have mentioned both side by side. HTTP you can say hypertext transfer protocol, which use to transfer your data over the network as a plain text. Anybody who is on your network tab, he can see what data is transferred from your web application to a server, and he can tamper it and he can update or modify your data, which is not good for critical applications. If you see HTTPS, which is hypertext transfer protocol secure, this is good, and this came over HTTPS. What all was issue, or we can say what was a security issue on HTTP, it is being covered on HTTPS. HTTPS you can see 3 point I have mentioned in the slide. First point, encryptions, which is protect data against eavesdroppings, which is protect data from a hacker. Because when you are submitting any critical or sensitive data, HTTPS secure your data, encrypt it through the encryptions, and pass from browser to a server, or browser to browser. Data integrity is again a critical point when you are looking a payment related application. Data integrity is something where you are going to protect your sensitive data from being hacked by any a hacker or anyone who is tampering your data. He cannot tamper if you are using HTTPS protocol. Data integrity is very important for the payment applications, for the sensitive data, for any kinds of data which is more sensitive and cannot and should not known by anybody who are not applicable to see your data, what is being transferred from network to network. That's what data integrity application. If you are using HTTPS, it is going to integrate, or it is going to encrypt your data and pass it through the network. Authentications, again, authentication is something which provide a way, or which provide a person who is applicable to see your data, that come under the authentication. Because let's suppose somebody or your application is sending some sensitive data from one network, from your web application to your server. Now, if your servers and web application has bonding to each other, then your data is going to be accepted by the servers and from the browsers, right? So what will happen when you are sending, or your application sending data over the network and your server is rejecting it, right? So in that case, your website, your server will not trust on your website what data your website is trying to send it to the server. Let me clarify about the server. What is server? Server is nothing. It is just a backend of your application where something you have deployed. Let's suppose if you are using Java applications and you have deployed your applications on a web applications or on Apache Tomcat or somewhere else, then the request that will come from the network, your server is going to accept or reject based on the authentication. And authentication is a part of your HTTPS encryption mechanism, because when your server and browser will trust to each other, then they will transfer, then they will accept their data, right? So next, you can see SSL and TLS handshake, right? How SSL and TLS are doing handshake between client to server. The previous few seconds back, I explained how your HTTPS is authenticating a data from server to client to server. Client is something called a browser. Right? From the browsers, any request that is coming to the server, here browser will behave as a client and the backend application behave as a server where your application is deployed. Okay, now you can see a short definitions that I have mentioned in the slide. It allows two strangers, a browser and server, to establish a complete secure encrypted channel over a insecure network without ever sharing private key beforehand. What it does means by this single line, right? So basically, as I said, when a data is transferring from client to network, client to servers, your application, your server and client must have a bonding between each other to transfer their data or accept their data. In between, there is a session key which is being generated by client, and same session key is generated by server. When client is sending some information and creating the session, your server is also creating another sessions, and both sessions are matched between, and then data, if they are matched, then data is being transferred between the client and server. Okay. So how they are doing key exchange? As I said, first client encryption, right? Random string. Let's suppose you are sending some information. Let's suppose you say hello client. Client is saying hello, right? The client send a TLS versions and support as a text, right? And server also said hello, and the server respond with the chosen TLS, transport layer security, right? Will be used, which cipher will be matched with the client. And if both are matched with their sessions, then they are transferring data between. If they are not matching, they are not going to accept their data to each other. The benefit here is if you are using HTTPS for encryptions, the very important and its benefit over here is if somebody due to some reasons knows the sessions, knows the keys which is being used by client and server, still he cannot tamper your data which was already passed, which was previously passed, because it is based on the session. Okay, so once data is transferred and session got expired, and if client knows or a hacker knows your session, right, keys, still you can he cannot tamper your data which is already transferred. He might not know about this. He cannot know. Now here is the point how the things is going to communicate between the client and server. Let's suppose client say hello. Client send a TLS versions and support Cipher Suite, right? Now server also says hello. Server respond the chosen TLS versions, Cipher Suite and its SSL certificate, like including public key. As I said, if your since these client and server are using a session, generating session to transfer their data between client to servers using public key. If somebody knows your public keys and want to see the previous data that is already being exchanged, he cannot see. He cannot decode your previous data which is already being transferred. Even he knows the public key. This is the good benefit or good things for while you are using HTTPS protocol. Authentications also I explain how key exchange, right? Client encryption, or as I say, you can say pre-master secret with the server public key, right? Modern, what it is using, it use Diffie-Hellman generate, right? Shared by without sending it. Session key created, as I said, both side independently generate a same symmetric session key. This is the one that I just explained few seconds back. And this session key are used to exchange the data between the server and client, and somebody knows your public key even, but still he cannot tamper your data which is already being transferred between the server and client. Now certificate types. Let's see different kinds of certificate. If you guys already done these kinds of certificates, this kinds of configuration in your organization's applications, that is good, but still let me give you brief about it, how many types certificate have, and by validating a level, what are different validation level is there, right? So here you can see domain validations, organization validations, extended validations, right? The CA only verify that application owns domain. If you are you are using a certificate which is only implemented or designed for the domain validations, then your domains is going to be protected by that certificate. And downside, you can see this is only for a blog and personal site. Let's suppose you are launching any website and you are to secure your domain, so you can use a certificate which is domain validations, and it can be issued within a few minutes. Organization validations, which is again very important for all organizations, because organization has a lots of secure or securities of their website they are keeping, because they have sensitive data, they have their employees, they have their own products, So they don't want to share their product informations, their employee informations, all those by a third person who don't have access to validate their website or maybe their information which is available in their website until organization are intentionally giving them uh, permission to access it. Right. So this is different. Second one, certificate types where CA verify the physical and legal experience of the organization, and this is best for the business website. Extended validations, this is highest level of ratings, right? And this involve rigorous background check on the company before issuance or issuance. This is best for bank and finance. So as a certificate already being categorized, domains validations, organization validations, and extended validations, and these certificates are being generated by CA, and it is generated by for individual levels, organization levels, and validation level. Now certificate types by domain coverage, right? Single domain. Sometimes we want to generate a certificate that should only applicable for a domain. If you have multiple domains, that will be not applicable for that. In that case, you can generate a certificate which will be applicable for a single website or single domain. But sometimes organization have, and again first single domains, this is only applicable for the personal website or for the blogs, which is individual for the users or organizations. But sometimes organization have multiple website, and if he will go and manage different certificate, then there will be a challenge for him to maintain them. So because of that, they prefer wildcard certificate types. They will use store.example.com, you can say abc.com, anything you can see, and this is going to cover entire their domains related website. Multi-domains, this is again protect multiple unrelated domains under one certificate, which means the domains you are, the certificate you are generating, that will be applicable for xyz.com domains, abc.com, .org, .net, right? So wildcard was something which was only support .com, and here you can see .com, .org, .net, everything. So this is very useful information when guys are going to request their organizations. You need a certificate which is you are going to configure with their organizations applications. You have to keep these things in your mind, what all information you have to communicate with your product owner, because maybe your organization has multiple domains and you are requesting only for single domains, which is not good. And in futures, when you will, a client will launch another one website, he will ask, you can go and use same domain, same certificate, then that is not going to work. So that's what you should be very careful before requesting for them or for any certificate with your organization or with your CA. Now certificate authority, CA, certificate authority. So every guys who already done or who is never done, let me explain here. Root CA, and there is an intermediate CA and your website. So basically when you are generating or your CA is generating some certificate, you should get that two certificate along with CA certificate. actual certificate. So there is a root certificate, there is intermediate certificate. So when you will combine these two, it will become a single certificate, because CA will share you root certificate, intermediate certificate, and you have to use this root certificate, intermediate certificate, uh, between each other, I mean in a group, and you will generate a single certificate, and then you will use that certificate. And here the point is root CA, a highly secure trusted organization whose root certificate are hard coded directly into your operating system or browser. So, because we are doing day to day such kinds of configurations, this is important for the learner who is new or freshers and who never work on it. This content will be useful for them to understand what is root CA and what is intermediate CA. Right. Intermediate CA, you can see a proxy CA, root CAs don't issue certificate directly to public website. If a root key were compromised, the entire internet trust system would break. Instead, root CA sign intermediate certificate, which then sign your website. So here's intermediate certificate is clearly explaining of when it is needed and why root certificate directly cannot be applied any your public website. You have to use intermediate certificate for that. Let's see public key with private certificate. Again, public key certificate issued by public organizations or public recognized CA like encrypt, right? Every major browser automatically trusts these certificate, and it will not give you a warning whether your certificate is not valid or something, right? So public certificate is be used in our applications. Here example you can see https :/amazon.com. So basically you are already aware what is amazon.com. So it is e-commerce website, and this website is using a public certificate. Even any website which is in the market, they are using public certificate because that is secured or recognized by CA, and this is majorly used browsers to know or trust about the certificate. Browser trust on your public certificate, and that's what it will give no warning. Downside, you can see browser trust it automatically and gave no warning for this. Private certificate, right side we can see issued by internal corporate certificate authority, active directory certificate service, HashiCorp Corp Vault. What is use case for this? It is used inside of corporate intranet or microservice architectures. Microservices, again, the key point, if you guys are aware about different kinds of microservices when you have exposed or how you are generating, this is all about you. But yes, private certificate are completely used inside corporate or microservices architecture level. This is basically used in public internet where your connection is not private. Now the point is key store with trust store. What is key store and what is trust store, right? When and we should use this one. In Java, our enterprise application certificate and keys are managed in two distinct storage files: key stores and trust store. A repository that hold your private keys and your identity certificate. What is purpose for this? The use of this certificate a key store is to provide who you are to other authentications. Analogy, you can see your passport or ID card. So basically this is key store point that you should know about. And trust store is again something, a repository that hold the public certificate of external parties you trust. Purpose, what is purpose for this? This is used to verify who other are, verifications. Analogy, here you can see the security guards database of accepted ID format. So trust store, sometimes if you guys aware about self-sign certificate, you might has generated it, and once you generated it, you want to store it as a trust store in your Java. You want to make sure your Java should allow your applications while you are installing your trust store, your certificate as a trust store. Either you can generate self-signed certificate, or you can get a CA certificate, and you can go and store in your Java, and the location would be JRE. Inside there will be security folder. Under there you will see a trust CA certificate, or there you can go and import your certificate as a trust store, and once you will store, then the application which is related to your certificate will allow by Java, and no issue will be backend, and it is going to work. Now implementation with Java key tools. How you can implement with Java key, how you can generate CA certificate with Java key. So here you can see what I have mentioned, generating a key store. How you can generate a key store. So this is command, using that you can generate it. And let me generate one certificate for you, and then in the next sessions we will see how you can configure it with your applications, where your application is going to run on HTTPS.